Alright, 7th grade, Chapter 3, Operations with Integers, Section 3.3, Multiplying Rational Numbers. Yay! No new vocabulary. However, this gives you an opportunity to review rational numbers, positive and negative numbers, absolute value, and other vocabulary from past lessons. Okay, today we are going to talk about a key concept, multiplying fractions. So in words, to multiply fractions, simply multiply the numerators and multiply the denominators. What does that look like? Alright, let's take a look with symbols. Okay, so if we have two fractions, a over b times c over d, you really can just combine the lines and multiply across. And thus you have a new fraction, a times c over b times d. However, it's important to note that in this equation, or in these equations in general, b and d cannot equal 0. As I've shown you over to the side, an equal sign with a line through it means it cannot equal 0. Okay, so if this is our number problem, our number example, we have 3 over 4 times 1 over 2. So we're going to rewrite that over one new fraction like we did above. And that will make it 3 times 1 over 4 times 2. And our final answer will be 3 over 8. And that's the basic concept of multiplying fractions. Okay, so in example 1, we're going to try this out. We're going to multiply fractions. So let's rewrite our problems to make it a little bit clearer. Okay, so now we have 1 over 6 times 2 over 3. Okay, so if we multiply our numerators, we're going to get 2 on the top of our new fraction for our numerator. And then if we multiply our denominators, we're going to get 18. Now, this is not simplest form, so we have to simplify it. 2 goes into both the numerator and the denominator. It goes into the numerator once, 1, and goes into the denominator 9 times. So our final answer is 1 over 9. And if we recall from last lesson, 2 was our greatest common factor, which is how we simplified. Now, we could have also simplified earlier in the problem when we combined our fraction into one entity. And let's take a look at how you do that. So I'm going to rewrite the fraction. Now, if you take a look at this, I have our numerators being multiplied 1 times 2, and our denominators being multiplied 6 times 3. But we can take a greatest common factor right directly from this problem before we multiply. So if we take a look at it, we can see that there is a greatest common factor between our 2 and our 6. It's important to note that you have to draw a greatest common factor from both a numerator and a denominator. You can't do it just from the denominator or just from the numerator. It has to be one canceling out the other. So in this chance we have 2 as a greatest common factor for both the numerator and the denominator. And let's see what that how that works out. Okay, so I'm going to divide that top numerator by 2, and I'm going to divide the bottom denominator by 2. And this will help me simplify before, so if it's larger numbers, I won't have to find the greatest common factor later. Okay, so here I wrote it out again after simplifying or taking out the greatest common factor, because 2 over 2 is 1 and 6 over 2 is 3. So I wrote it out as 1 times 1 over 3 times 3. And as you see, that's going to actually come out to the exact same answer. So either way can work. Okay, so in example 2, we're going to multiply negative fractions and mixed numbers. Again, the first thing I would do is rewrite it to make it more clear. Okay, writing it out like this, right away I see a greatest common factor between 3 and 9, which is 3. So I'm going to take 3 and divide it by that numerator and denominator to make things a little bit simpler, because I don't like working with large numbers. And there you have it, and I'm going to rewrite the fraction all over one line. Okay, and so now I have, instead of 3 times negative 7, 1 times negative 7, over, instead of 4 times 9, 4 times 3. And that's going to come to negative 7 over 12. Alright, for the second problem, the first thing I'm going to want to do is make everything into a single fraction instead of mixed numbers. Okay, and I do that by multiplying my 2 by my 3 for the one mixed number and my 2 by my 7 for my other mixed number, and adding those to the numerators that are already there. I'm going to highlight those. And as you can see, I have my new just fraction. And so I'll have 6 plus 1 over 3 and 14 plus 5 over not 3 but 7. Okay, you may be thinking that you want to simplify these right now. However, you have to make sure you add them first. Because 14 and 5 are being added, you can't simplify 7 and 14. Alright? And same with the other side. You can't simplify 6 and 3. You have to add them first. Only if they're being multiplied can you simplify like we have done before. So now that I have my two fractions, I can draw a line under them. I'm just going to do that right here and multiply across. Okay, so looking at this, I'm thinking, yes, I see a great greatest common factor that can make this problem really simple in 2 seconds. And here it is, 7. 7 over 7, anything over itself is going to equal 1. So let's do that. I'm going to cancel and cancel. And then it's really just 1 times the numerator and 1 times the denominator. And really I did that by dividing both sides by 7, as you can see here. So when we write that out, and so we have it 1 times 19 and 3 times 1, which is equal to 19 over 3, or 6 1/3. Okay, so in example 3 we're going to evaluate rational expressions using multiplication. Remember, rational means it can be written as a fraction. Okay, so the first thing I want to do is rewrite everything in a fraction form. So here I have A, which is equal to 6 over 7, and B, which is equal to negative 4 over 9. Now my equation that I'm evaluating is 1/2 times A times B. So I'm going to rewrite the entire thing out as fractions. Okay, so there you have it, 1/2 times 6 over 7 times negative 4 over 9. And again, I color-coded it so you can see where they're coming from. So here I'm noticing 2 greatest common factors, 1 for the 6 and 9 and 1 for the negative 4 and 2. Let me write this all under one line. Okay, and there you have it. So for the 6 and 9, I see the greatest common factor is going to be 3, so I can simplify those by dividing both by 3. I also see one between the negative 4 and the 2, so I'll divide 4 by 2 and 2 by 2. So let me rewrite this whole thing to make it look a little bit clearer. And there you have it. And remember, everything's being multiplied. So I'm going to multiply these. So now all that's left is to multiply by across, numerator by numerator, denominator by denominator, and I have my answer, which is negative 4 over 21. In example 4, I multiply fractions by whole numbers. So let's read out the problem. The first drop on a certain roller coaster is 255 feet. The first drop on another roller coaster is about 11/20ths as high. Find the height of the drop from the second roller coaster. So the 2 things I underlined that caught my attention was the 255 feet from the first one, and the second one being 11/20ths as high. So when you have a fraction of something and you're trying to figure out what that equals given the height of something else, or amount of something else, you always multiply that fraction by what you have. So if you have a full pencil and you want to know how much, and there's another pencil that is 1/2 as big, you would multiply 1/2 by 1, and you'd get half the size of the pencil. So we're going to multiply 11/20ths by 255. Okay, so I rewrote the problem. 255 over 1 to make it a fraction times 11 over 20. So as it turns out, 5 can go into both 255 as well as 20. So I'm going to make these numbers a little bit easier. Okay, and so here I have it 51 times 11 over 1 times 4. And I simplify, and my final answer will be 561 over 4, or if I simplify that further to a mixed number, 140 and 1/4 feet. Alright, thanks guys.
Made with Doodlecast Pro.